Welcome, ladies and gentlemen, to a new episode of Playing with Junk. Yes, you heard me right, I said ladies and gentlemen, because I have seen that 3% of my viewers are women. And, well, of course, 97% of my viewers are men, or persons who clicked the female or male button on the registration. However, welcome, ladies and gentlemen. Today I have this beast here. It's one of the power supplies of the, I think it was the Z9. Could also be the P5, one of the big IBM mainframes. And the interesting thing here is the label on the back side. Okay, not only the label, but that too. And that label tells me input 350 volt DC, output 1 volt 800 amps, and then 1.5 volt, 175 amp, 1.8, 3.3, 3.4, and also a lot of amps. So you may ask yourself now, 800 amps, 1 volt, what? Well, this power supply here is supplying power for the CPU chip directly. So that's the 1 volt voltage. And well, there are a lot of other things. So this is mainly for the CPU module, CPU chip, 3.3 volt for the peripheral chips and so on. Interesting, here you have a MAC address. This means the controller here has an Ethernet connection. So the whole system, or all the parts of the system here, have Ethernet connections. That's the way how they transfer data, how you switch it on or off through the Ethernet. And you also get some messages about temperature, currents. This is all managed by the two laptops in the front. And as some other YouTubers say, don't turn it on, take it apart. Well, turning it on is a little bit difficult, because for that we need the rest of the system, and the rest of the system is already gone to the scrap yard. There have been a lot of comments about, why don't you sell this machine, it is worth a couple of grands. Yes, that's right, but the problem is the market is very small for that kind of machine, and the people who normally buy this kind of machine, they want a new one, they don't want an old one. So, and for a hobbyist, well, if you have the necessary equipment to the necessary power connection and all this stuff, and transportation is a problem, because to move 1 metric ton of material across the world, you easily spend some thousands of dollars only for transport. And just for fun, there are not so many people that want to do that. Okay, how does it get up? This sticky, okay, that way. So that's the first power brick. You only see a big heatsink with some components, some transformers, I think it's a similar construction or a similar circuit as in the HP power supply from the C7000 that I took apart in another video. This is an interesting thing here. Seems to be a current sensor thing. It's a ferrite core that goes around the positive and the negative rail. So there is where the other board here gets clamped in between. And we have some little chip. Cannot see the number, will tell you. What is it? It says 33078 PKKQ. That's probably a date code, so maybe you can see that by yourself. I'm not sure if this is a magnetic sensor or probably the two transistor-like devices here. And the funny thing is, you have this arrangement on both polarities, on the positive and the negative side. Well, maybe it has another purpose than measuring the current, but at the moment I really don't know. Well, because this is the only connection here, this 4-point connector. Okay, let's see what the other bricks look like. Okay, I think I get it. It's not positive negative rail. This is two different voltages, probably. Let's see what this one does here. No, I have to unscrew it completely. Yes. Okay. Okay, I get it. It's not the same polarity. This is probably positive and the other side negative, or vice versa. You can see it here. The upper connector goes to the upper side of the board and the lower connector goes here. So this is a you can do this because the voltage is very low. As you see, we have 1 to maybe 3 point something volt, so you can keep them close together without danger of sparking or stuff like that. The construction is the same, looks very similar, although we have here probably two different voltage. So we have, let me see, on the other side we have 1, 2, 3, 4, okay, let's say 3 voltages with more than 100 amps. So I think these two here work in parallel, and this does the other two voltages, because especially on the 1 volt rail we need 800 amps. That would be 400 amps per module, which is still a lot of current. Okay, you may have noticed that I already have removed some plugs and some screws. I only put it together with the minimum amount of hardware, so this looks exactly the same. By the way, these two bricks here, they have the same part number, assembly number 76F0122. This one is exactly the same. So that's why I believe these two bricks run in parallel, 400 amps each, 1 volt. And then we have 1.5 and 1.8 volts. It's probably these two here. Okay, what else do we have? So I just removed that controller board here. A lot of IBM specific chips. The MAC address is here, so I assume that at least one of the chips is responsible for the Ethernet connection, or maybe they made some microcontroller chips with embedded Ethernet or whatever. Just the aluminium box, some insulation, some more flash RAM stuff, not too much on this side. Then maybe you can see part numbers here, 41M9549, another IBM specific chip, and another one, and the rest is a little bit, oh, here we have two Broadcom. Broadcom, how much? Sorry, I have to use the magnifier. BCM5221A4K, and so on. Two Broadcom chips, two transformer assemblies. So I would say this one goes to the Ethernet port of that card. Oh, this is the Ethernet port, a little bit an unusual connector, but it goes to the backplane, it goes somewhere, and at one point it will be a normal RJ45 connector. Okay, then here we have another big board with a very unusual construction. Let me move that a little bit. So it seems that we have here, oh, it's also pluggable. No, I thought this was a DC converter, but it doesn't look like a DC converter. But we have one, we have two of them. Oops, we have 3, 4, 5, 6 of them. And they are labeled level 1, level 2, level 3, level 4. I guess this is level 5 and level 6, whatever it means. There are some part numbers. Maybe it's the part number of that board that reads, oops, focus you fuck. Okay, it works, yeah, great. We always learn from other YouTubers. 76F0988, and it says 76F0988 belongs here. Okay, it's for the stupid technician who mixes up all the boards. Then we have 76F1343, that's this one, okay. And even if I mix it up, I will still find the right position for 76F1535. It's that one. So clearly these boards are not the same, although they look exactly identical. But maybe, okay, there's, for example, a difference. There are two chips. There's only one is missing. There's also one. Some other difference. No. Okay, there's a difference. Here we have 2 chips, 1 chip, 1 chip, 1 chip. So they are configured with different components. Maybe they are made to control different voltages or whatever. Oops. Okay. Doesn't matter. I got something wrong here. I'm the most stupid technician, cannot read the numbers, but I will never switch that on. Probably. Maybe one of these modules, I don't know. But it could be a bit difficult to do. Okay, here we have the connectors that go here. Then we have a lot of stuff around here. We have some Intel, what is it? L7320 and a something. Okay, a lot of Maxim stuff. Maxim Max, that sounds a little bit like a serial interface. Max 306 EQI. Okay. Maybe we will find out what it is. And we have an array of resistors. So this is probably more the analog or power supply control board. The other one here is more the management board that delivers data through the network. Okay, let's have a closer look to the board. That's the connectors where these power bricks connected. You remember one side of the PCB positive, the other side negative, or maybe the other way around. I don't know, I have no manual for this. Input connectors are on this side, J00 and J01. It says more than 200 volts. Yes, it's 350 volt DC. The 350 volts come from another power supply, the main power supply. It's a 6 kilowatt 3-phase input, mains input power supply that provides 350 volts DC to the entire system. For example, the fans are running directly from this 350 volt DC. Of course, with a speed controller interface, brushless converter and stuff. Okay, we have inputs here. So this is mainly input filtering, a lot of input filtering for each power brick, one complete set. We have a lot of coils, capacitors, more coils in fancy plastic housings. I don't think this is too much active stuff, it's more like redundant, maybe switching, but I don't see any relays or other stuff. A small transformer, that could be some sort of standby power supply, for example to power up the Ethernet controller, which is then used to power up the entire power supply. Here in this corner another sort of switched power supply, big capacitors, everything glued with silicone rubber, very strong, no flapping in the breeze. They even have their own part number here, 75F, blah blah blah, blah, on the ferrite cores here. So they are custom made for IBM. I think they are not made by IBM, but certainly for IBM. And then Oops, on the other side we have the power connector, where all these amps and more amps and hundreds of amps just go out to the back plane. Then some data pins and more power pins here. Yeah, there is not too much written on the board. Assembly 300. Yeah, that's about it from the big board. Okay, let's start with one of these presumably 400 amps power bricks. Let's find out how that comes apart. I haven't tried that before. Okay, I see there are some plastic screws on this side here. This is probably the high voltage side, so that's the reason why they used plastic screws for insulation reasons. Don't know. Okay, it seems that there is a little bit more than only, yeah, there's a lot of soldering. Okay. Let me pause my camera and I will do some soldering here. Okay, I was a bit lazy. I cut some of the connections with my snips and desoldered the other ones. So there is something I missed completely on the big board. I will show you. Oops, don't destroy the camera. Okay, I was completely missing the primary switching transistors, which are here under this relatively small, I would say very small heatsink. You can see them. There are 4 big transistors, because if you look at the connector here, this is the connector. You see the holes. On the other side is the connector block. The connection is made through the board, like that one. Comes on this place. The connection goes through the board, through the connector. You can see it here, the result. The connector sticking out. Maybe the reason could be a better connection than just have it stick it in from this side. I don't know. But you can see that these 2 connectors go directly to the transformer, and that's certainly the primary side, so the switching must be somewhere on the main board here, and this is exactly here. I wonder that there is not much active circuitry around. It's only the switching transistors and then a lot of coil stuff, a couple of capacitors. Maybe there is something on the back side of this board. We will see that a little bit later. Let's have a look to the power brick again. Okay, there's some circuitry on this side, some drivers perhaps. There's not too much on this side, some connections that go to the other board. And this looks pretty nice. I could choose that as the title picture for my video. Looks really nice. I think I have to do a photo of that. That It's a nice feature of this camera. You can take pictures while you are filming. Okay, main transformer, big power rails. You won't believe, I mean, these two little transformers probably put out 400 amps. Then we have rectifiers, a similar thing as on the HP power supply, which I explained a little bit closer. Then we have, what is this? 0.15 microhenry, 120 amps. That's an inductor for 120 amps. So we have 1, 2, 3, 4. That makes 480 amps. We are only using 400, so we have a little bit of reserve. We are on the safe side. Then we have some capacitors here. What are they? 33 watt microfarad probably. Let me see, where is my glass? My magnifier. It's just 33. Yes, could be microfarad. And then some switching transistor here, some sort of MOSFETs. You see this kind of package sometimes on main boards for the DC converters. Yeah, it's mainly transformer, rectifier, switched rectifier, some inductance for filtering, some capacitors, output switching, probably to switch the entire output on and off. And then we have a similar arrangement as on the other board. A big ferrite core goes around both polarities. So in fact the magnetic flux, okay, it has a core in between. I can't say what exactly they are doing here, because if you have the same current, positive, negative, it would cancel each other out, so the magnetic field in this core would be 0, but probably they made something different. And now it's church time, time for a little pause. Okay, I used that little break to remove the metal frame from the board, or the board from the metal frame. Let's see if I could place my lights a little bit better. Okay, so that's the back side. We have here, oh, they are not that big. I thought it's the bigger case of transistors. They are relatively small. Do we have transistors? Okay, we have more transistors on the other side. So there are 8 transistors per channel. And you probably notice this massive amount of silicon glue here around the pins. As I said, the input voltage is 350 volts DC. They use this small transistors here, and the spacing between the transistor legs is very small, so they use the silicon glue also here on the back side to prevent any arcing of this high voltage, especially in a server that runs 24 hours a day. So sooner or later some dust will accumulate, and if the dust accumulates here between the transistor connectors, that's a bad thing, because one little arc at 350 volt DC, and the entire board is toast. So we have more insulation here. Maybe it's also a primary thing. Yes, it has a similar heatsink, only 4 transistors. Maybe could we see what kind of transistor it is? Probably not. Let's zoom in. What is it? Well, until you see it here now on the big screen, I see it on the small screen here. It's some IRF. It's hard to see for me, maybe. Yeah, oops, that's a little bit too close. IRF 1B7N50. What's that? 700 volt, 50 amps. 500 volt, 70 amps. Something like that. Okay, let's see if we can see the main transistors here. What is it? Is that the Toshiba logo? I see a lot of 3 something. Maybe we find one that is a little bit less gunked. No. Maybe this one. No. No chance to see. Maybe on the other side. Whoops. Let's test the upside down reading capabilities of my viewers. No. They gunked it very well. No, I can't see that. Well, it will be some sort of MOSFET, probably voltage 500, 600 volts and as many amps as possible. Okay, I think that's all I can say about this. If you have any comments, please place them in the comments. If you like my video, you know where to push the button. And if you want to subscribe, there is also a subscribe button here, or here, or here, somewhere below your screen. Thank you for watching.